Hello students, in this video session we're going to discuss regarding folate trap. So folate trap is a concept which comes under vitamins chapter. Vitamins. There are two vitamins involved in the folate trap and they both come under B complex series. B complex vitamins, which means water soluble vitamins. Now we'll see what are they. The first vitamin which is involved in folate trap is folic acid, obviously folate, folic acid. And the second vitamin will be vitamin B12. So the name of vitamin B12 is cobalamin. Remember the basic things. Cobalamin. Okay, the name of the vitamin is cobalamin and it has a series number in B complex, which is B12, the last vitamin. B12 is the last vitamin, and folic acid is a B9. Okay, now see, we'll explain the folate trap. Simple folate trap is nothing but folic acid is getting trapped due to what? So we'll see why the folic acid is getting trapped. Okay, this is the question. At the end of the session we'll write the answer due to what the folic acid is getting trapped. Folate trap is nothing but folic acid trap. Okay, now so I'm going to write a reaction over here, so I'll explain while writing it. Okay, so folic acid in our blood is available in different forms, depends upon the carbon atom attached to it. Okay, for example, this is a form of folic acid, N5 N10 methylene. Let me write little left over here so that the whole reaction can hold the screen. So N5 N10 methylene tetrahydrofolate. So this is a form of folic acid. This will be converted to N5 methyl tetrahydrofolate, short form. Okay, THF. So these two are folic acids only, folic acid forms, N5 N10 methylene tetrahydrofolate and N5 methyl tetrahydrofolate, both are folic acid forms. Okay, so N5 N10 methylene tetrahydrofolate will be converted to N5 methyl tetrahydrofolate. So this is 90% of folic acid in our blood is available in this form, N5 methyl tetrahydrofolate. Now we should utilize this N5 methyl tetrahydrofolate. Just see how we are utilizing this N5 methyl tetrahydrofolate. See here, this N5 methyl tetrahydrofolate, how we are utilizing this one. Here we have cobalamin, which is called what I have already told you guys, like cobalamin. Cobalamin is vitamin B12. Okay, cobalamin, which is vitamin B12 form. This cobalamin accepts or takes methyl group. This N5 methyl group will be taken up by this cobalamin. Okay, as soon as this methyl group is taken up by the cobalamin will be converted to methyl cobalamin. Okay, methyl cobalamin. Simple logic. When you give methyl group to the cobalamin will be converted to methyl cobalamin. That's all. Okay, when this N5 methyl group is transferred to the cobalamin, what is left here? Only tetrahydrofolate. This tetrahydrofolate will come down and involves in 1-carbon metabolism, which is a major function of folic acid, 1-carbon metabolism. Tetrahydrofolate, this one THF, involves in 1-carbon metabolism and reconverts back to N5 methyl tetrahydrofolate for the cyclic conversion of cobalamin to methyl cobalamin. Okay, now just see here. So methyl cobalamin is formed. Methyl cobalamin is also form of B12, one of the form of B12 containing methyl group that was taken up by the N5 methyl tetrahydrofolate. Okay, now see, in our body we have essential and non-essential amino acids. The one which we take is essential, right? Homocysteine is an amino acid which is essential amino acid. So if you eat homocysteine, it will be converted to what? Methionine. It will be converted to methionine, which is non-essential, which means you need not to take in a diet. Your body will synthesize from homocysteine. You had homocysteine in diet, right? So how homocysteine is getting converted to methionine? This is the concept here. Okay. So how it is converting? Directly homocysteine cannot be converted to methionine. There is a process through methylcobalamin, this B12. Okay. There is an enzyme called homocysteine methyltransferase. Let me write that one. Okay. Homocysteine methyltransferase. This is an enzyme which requires a coenzyme to be activated. Okay, so which requires a coenzyme. Now who is coenzyme? This methylcobalamin, B12 form of methylcobalamin is a coenzyme which activates this homocysteine methyltransferase. Once homocysteine methyltransferase enzyme activated, this homocysteine methyltransferase enzyme takes up this methyl group from methylcobalamin and shares to homocysteine. Okay, the activated homocysteine methyltransferase by the methylcobalamin shares the methyl group to homocysteine. As soon as methyl group is added to the homocysteine, the methyl group added homocysteine will be converted to methionine. Okay, once the methyl group is left from methylcobalamin, this will be again remained as cobalamin and ready to take up another methyl group from the N5 methyl tetrahydrofolate. Okay, so this is how homocysteine is getting synthesized. Methionine is getting synthesized from the homocysteine by homocysteine methyltransferase enzyme. So this enzyme requires methylcobalamin B12. Now we'll see what is folate trap. So here is the main concept, folate trap. So folate trap means, here you can see, here I wrote N5 methyl tetrahydrofolate. CH3 means methyl, right? So the basic chemistry. So for example, N5 methyl tetrahydrofolate, this one is available, readily available. Okay, but there is another vitamin called cobalamin, B12 vitamin. For example, if the person is deficient of B12 vitamin, if the person has low levels of B12 or deficient of B12, what happens? There is nobody here to take up methyl group from the tetrahydrofolate. Okay, N5 methyl tetrahydrofolate role is to donate methyl group to the cobalamin. If cobalamin is absent, which means if the person is deficient, who will be there to obtain methyl group from the tetrahydrofolate? There is no one to take up the methyl group. But this N5 methylene tetrahydrofolate is continuously synthesizing N5 methyl tetrahydrofolate, but there is no one here. So due to this reason, this N5 methyl tetrahydrofolate will be increased. Okay, so now see what is folate trap here. And due to the absence of cobalamin or vitamin B12, the formed N5 methyl tetrahydrofolate is getting trapped and accumulated. Got it? So that is called folate trap. Now let me write it. Okay, due to what? Folic acid is getting trapped due to what? Vitamin B12 deficiency. Okay, so this is how folic acid is getting trapped due to vitamin B12 deficiency. So in this concept, you understood how vitamin folic acid and B12 both are correlated, and this will be your university short question which fetches you 5 marks. So don't forget to watch this video and try to make a notes. Thank you.